Today I'm going to do a very quick walkthrough of building a 3D model of a ball finial with a hand-hammered metal effect, very much like these ones from Restoration Hardware. These are really nice finials, but can be expensive if you need a lot of them. But if you have a 3D printer and some metallic paint, you can create a really good facsimile of them. So let's get started. The first thing to point out, in my Blender, I've set up a default scene that emulates the size of my 3D printer, MakerBot thing-o-matic. So I have a cube that represents the heated build platform. It's roughly 120 millimeters square, and I've set my environment to work in millimeters. So sometimes things I add from Blender will be really wrong, and I have to resize them immediately, and others will be fine. But let's just jump in and I'll show you how this goes. So first thing we need to do is to add an icosphere. And here's one of those cases where the default Blender icosphere is way bigger than my default scene. So let's go ahead here and set this to 25 millimeter radius. That's better. And 3 subdivisions is fine. And if I pump the location up to 25 millimeters on the Z, that puts us sitting on the build surface. So that's good. So you can see that this actually kind of starts to look already a little bit like that hand-hammered finial, but it's way too consistent. And that would be a dead giveaway that this is not hand-hammered. So we can rough this up a little bit with a few simple modifiers. First, I'm going to add a Decimate Modifier. I'm going to pull this ratio down, and as I do, you can see it starts merging points, and I get to about 50% ratio. And it's definitely not uniform anymore, but it's also just kind of blocky and a little ugly. So next I'm going to add a subdivision surface, and that smooths things back out a little bit, and that looks pretty good. However, I'm going to do one more pass of a Decimate, and I'm going to again pull that ratio down close to around 50%. And again, you can see that now I've got a good mix of small facets and large facets, and that definitely looks somewhat like the hand-hammered ball that we saw from the store. Finally, the one thing to do is to add a bevel, and this is going to be incredibly subtle, but you can see that all of those joints now are slightly flattened. And that was something that we saw in the metal ball. So that right there is our hand-hammered ball. Now let's add the base of the finial. For this part, we're just going to add a simple cylinder. And again, the default cylinder size is way bigger than my environment, but we can work on that. First, I'm going to turn the vertices up to 48 for a relatively smooth circle. The radius I'm going to do around 15 millimeters. That'll be a 30 millimeter diameter. And then the depth is certainly way too big, so let's do 20 millimeters. And already we have a nice view there, but I'm going to move the cylinder up to 10 millimeters, and that puts it on our build platform. So that's actually kind of nice right there. However, I am going to move our ball up just a little bit, give a little bit more space to the base, and I'm going to add a little bit of flourish by adding a torus. And if we look here, turn the major radius and just start to increase this up until we start to see the torus just extending beyond the edge of our cylinder there. And the minor radius, just want a really subtle little bend there. And I'm going to go ahead and pull that up to where they meet. And that just gives us a nice joint between the kind of flat cylinder and the hammered sphere. So that's nice. The next thing we need to do is to add a cylinder for where the screw will go into the finial. However, we need to go ahead and merge all of these objects before we do that so that the screw goes all the way through both the base and the ball. So let's go ahead and if we select our ball, we can see we still have all these modifiers. Let's go ahead and apply them from the top down. Those are locked in. Now let's go ahead and add a boolean, and we want our cylinder. We're going to say union, and then we're going to add another boolean and select our torus, and again union, and that is all joined. Let's go ahead and apply these. Now we can come back up into our scene and turn off the cylinder and the torus, and we are left with just our icosphere object, which is now includes the base and the torus. So that's good. Let's go ahead and add another cylinder. And this cylinder, so the screws that I have are 6.1 millimeters in diameter. So because I know that there's some shrinkage with the plastic after it's printed, I'm actually going to make a cylinder that's 6.2 millimeters. And to do that, my radius is then 3.1 millimeters. And then my depth, I want to be, we can do a 30 millimeter here. It's not terribly important because all we're going to do is cut this out. But I do want to make sure that it extends far enough into the ball for the screw. So I'm just going to bring this up here, and it's just poking out a little bit there at the base. So again, we can select our icosphere, add a modifier, a boolean, and now we're going to select cylinder 001, and we are going to say difference. And that doesn't look like it did anything, but if we turn off cylinder 001, you'll see I have my nice screw hole there. So that looks good. And there is my hammered ball finial. Alright, time to send to the printer. So here you can see a finial that I printed on my thing-o-matic. You may notice that it's a little bit different than the one that I modeled in the example. I added an additional kind of embellishment there at the base, but for the most part it is the same. And then, after a little bit of paint, this is Modern Masters metallic paint, a color called Smoke. It looks pretty good. And then finally up on the wall, no one's going to really know the difference between the 3D printed one in plastic and the real metal one unless they were to get up there, and without a ladder that's not going to happen. So there you go.